The chance process, that is the set of all possible outcomes, is we will call that sample space. And usually this is denoted by an S equals and then some brackets. So right above that, let's take a look at example. If you flip a coin 2 times, I could get heads, heads. I could get heads, tails. I could get tails, heads, or I could get tails, tails. And those are my total of 4 possibilities. If I flip a coin 3 times, I'm actually going to be able to get 8 different outcomes. I could get heads, 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 tails, heads, tails, tails, heads, tails, heads. I could get tails, tails, tails. Tails, heads, heads, or tails, heads, tails. And those are all my different outcomes of flipping a coin 3 times. If I wanted to talk about, taking a look at a dice and adding 2 dice, this is a larger outcome. But if we draw a picture, you could get a 1 1, a 1 2, a 1 3, a 1 4, a 1 5, and a 1 6. So notice there's actually 36 possibilities because there's 6 sides on each dice. 6 times 6 is 36. The collection of outcomes from some chance process is called an event. An event is a subset of the sample space. And usually we use capital letters to denote that. So for instance, let's just say let's call A the sum of 2 dice is 5. Well, let's think about how we could roll a 5 on 2 dice. You could say, so the probability sum equals 5. Well, you could get a 1 and a 4, a 2 and a 3, a 3 and a 2, or a 4 and a 1. That's a total of 4 different possibilities. So the probability of the sum is 5 is 4 over 36. Let's say I'm actually going to change this to B. Let's just say event B is sum is not 5. Well, we know if there's only 4 ways to make 5, then there's 32 ways not to make 5. So the odds of that is 32 over 36. It's only 4 different rolls of 2 dice give me 5, so that means all the other ones don't give me 5. Last one, let's take a look. Let's say the probability is we get 2 out of 3 heads. So we're flipping a coin 3 times, so we want 2 of the 3. Let's go up here. There's 1. There's 2. And there's 3. None of these ways actually give 2 heads. So we have 3 out of 8. Mutually exclusive, also known as disjoint, is no outcomes. They have no outcomes in common, and they can never occur together. That is, P and B equals 0. And a good thing, or like a good example, is if I say probability of A is today is Saturday, and the probability of today is Tuesday, well, you can't have that. It can't be Saturday and Tuesday. Nowhere in the world is time zones that spread far apart. So those are disjoint, and there's no outcomes in common. So the probability of it being Saturday and Tuesday is 0. If you flip a coin once and I say it lands on heads, but I also say lands on tails, well, if I flip once, it can't land on both heads and tails. It's either one or the other. It can't be both. So that would have a probability of 0. Go ahead and think of two things that can never occur together, and you can fill in the blanks there. Some basic probability rules. For any event A, the probability has to be in between 0 and 1. When people say it's a probability of 1.1 of winning or 110%, well, mathematically it's just not true or accurate. The sample space, if S is the sample space in the probability model, then if you take a look at the entire sample space, then your probability is 1. Because if I look at this example, and I want to include all these events, well, I have 4 different events, and I want one of them to occur. One of them has to occur. So the probability of that is 1, or 100%. Equally like outcomes of probability of A, that is the number of outcomes corresponding to A divided by total number of outcomes in the sample space. And that's just like, hey, what are my odds of getting heads if I flip a coin twice? And we knew that if it was heads tails, tails heads, or tails tails. Well, if this is my sample space, only one of them is heads. So 1 out of 4 is 25%, or 0.25. The complement rule is just saying you don't want A to occur. And so you could rewrite that as 1 minus probability of A. So if I said I don't want heads, it'd be 1 minus 0.25, which is 0.75. Or what you could have done is you could have counted up all the non-heads, and you got 1, 2, 3, and you got 3 out of 4 that are not heads. And notice your answer is the same for that.